I'm Dr. Paul. And this section in Muscle as Medicine is a series that we're doing on helpful therapies, muscle as medicine. Part two today that we're going to do is actually how is muscle medicine. So we talked about, cardio versus resistive, et cetera. But why does more and more modern science point to the fact that the activity of muscle in the body, so skeletal muscle that moves your body around, and as we've said, the most important ones, they're all important, but the most important ones for muscle effect are going to be your legs, your arms, shoulders, and chest, and then your core, kind of in maybe in those order, maybe a little different. But there's something about muscle that has more of an effect than just doing resistive exercise and burning some calories or building muscle mass, et cetera. If you recall back from the resistance versus cardio little video that we did, there's also a metabolism shift that goes on. Your entire body's metabolism changes. And with resistive exercise, where you're building muscle, that metabolism change can be for 1 to 2 days after a workout event. And so what does that mean? Your metabolism is it's the sum total of the activity of your cells. Now, if your metabolism is slow, you will be more fatigued, you may sleep more, you may have more of other problems. You will gain weight easily because you're not burning energy at the same rate as you used to when your metabolism was faster. Your brain will work more slowly. All sorts of things go on when your metabolism slows down. And your metabolism, as I said, is the net effect of all of the cells in your body. But your mitochondria that are in all of your cells, which are what create the energy for your cells. So that's very important for having energy, having living cells, having healthy cells. But as the mitochondria are creating energy, if the metabolism slows down, they slow down. And if they slow down, the metabolism slows down. So one of the things about doing some resistive work is you can start to get the mitochondria back online, and they will work better and better the more resistive exercise that you do. Now, the idea of muscle as medicine kind of has this other side beyond the metabolism shift. If muscle is so good for you physically, makes you more resistant to many diseases, it is associated, more muscles associated with longer life, with cancer survivorship and many other things. So if muscle is doing all this good stuff, is there sort of a counterpoint? In most good stories, you've got the hero and the villain, right? In those roles, sometimes you have an anti-hero, or something like that. So in this story, you kind of have a hero and maybe a villain, or maybe an anti-hero, because really the anti-hero here, the villain, is a part of you that has to work also. It's just that in modern life, it tends to work more, and so the balance is off. So it's not that we're going to vilify one or the other group, but we're going to talk about it in terms of, this is modern life, this is how things work now, and this is why your body may not be reacting the way you want it. So if we're going to call muscle mass, muscle activity as the hero in the story, then fat metabolism is going to be the anti-hero or the villain. Now, everybody has to have fat. We have to have fat to make hormones. We do all this other stuff with fat. It's just that in modern times, we tend to build more fat than our body really needs. And here's a problem. It's not just that you look bigger if you have more fat cells. It's that your metabolism shifts. And many people don't realize that. Pushing your muscles to work pushes your metabolism in one direction. Not having your muscles work and preferentially stimulating your fat metabolism pushes you in another metabolic direction, which is why we're calling this the anti-hero, and it makes you less resistant to disease, more inflamed, less likely to survive traumas, less likely to survive cancer, et cetera, et cetera. So what is it about this fat metabolism? Well, fat metabolism goes hand in hand with insulin balance and metabolism in the body. And so one of the things that's been known, for a long, long time, even before the biochemistry was really worked out, for example, was that people with insulin sensitivity problems, diabetics, et cetera, would do better if they worked out their body, if they did something resistive, et cetera. Well, part of that is because the muscle action is going to shift the metabolism back to more of a healthy metabolism, and it's going to down regulate some of the fat and insulin inflammatory reaction that goes on. So what is it about the insulin release and fat storage connection that goes off the rails in modern times? Because I keep talking about modern times, things are different. Well, the thing that happens is that, number one, when you eat a carbohydrate, you are going to trigger a response by your pancreas to release insulin, which is fine. That's what we want. Because what does the insulin do? It goes out, binds to the cell, and then the sugar can go, the carb can go into the cell and be used as energy. But in about 45 to 55% of people in North America, they have a spectrum, because of genetics and other things, of insulin resistance that develops, meaning insulin goes out, it binds to the receptor, it doesn't work so well, so we make more insulin, it binds the receptor works, and we keep doing this, and the receptors get slower and slower and duller and duller. Now, the problem with this is not the sugar going in the cell part. That's sort of, at this point, that's doing its thing. But all this extra insulin that is made is sort of like, an unattended child who has a weapon or something. It's going to run around and do things that are unintended. And so what happens with insulin when we start to have too much of it floating around is a number of inflammatory things go downstream. Number one, these are just the order I'm, saying them in, they're not more or less important. But number one would be it shifts your inflammatory fat biology in your cell membrane. So the eicosanoids that we think of, like the omega oils, like omega-3 you've heard about, or 6 or 9 or others, and then arachidonic acid, which is a relative, you start to preferentially take one group of those and metabolize them more towards the inflammatory side. So your cells actually get more inflamed when there's too much insulin around. The next thing that happens is your fat cells become hypersensitized to convert excess amounts of other food product and nutrients that you've taken in into fat to store for later. Now, in non-modern times, that was really useful when you'd have famine and shortages and pestilence and stresses and stuff like that. But in modern times, at least in the Western world, we don't have a lot of famine. We don't have those sort of things. And so our body just goes into this evolutionary system that it does, and it stores fat. So beyond, fat storage and your cell membranes getting inflamed and all that, there's a lot of other chemistry that the excess insulin triggers. And that chemistry can be very deranging to your immune system and your immune function. And so part of the reason it's believed that this balance between muscle and insulin and fat activity is so critical is that in modern times, we're sort of overdoing the inflammatory side, and we're not attending enough to the muscle action in our body and building muscle, et cetera. So the idea that muscle is the counterpoint to insulin and fat activity is very important, because the more we work the muscles, the more we have them do resistance activity, the better our metabolism shifts towards the healthier, and a lot of the inflammatory chemistry goes down and down. Now, there's obviously a dietary component here. You can't simply just work out all the time and drink sugary beverages and eat carbs and all that stuff, and expect that the muscle is going to outcompete your diet. But you've got to kind of put them both together. So for instance, when we're talking to chronically ill patients or cancer patients, there's a lot of different types of therapeutic diets people do. We've talked about many of them here, but the thing that we try to focus on is the core of the therapeutic diet for chronic illness and cancer is going to be to keep insulin release in your body to a normal minimum, meaning I want enough, I don't want too much. Okay. And for most people, that is manipulated by their diet. So the best way to help and the best way for muscle to actually be medicine is to actually work the muscle so that its metabolism increases. Part of the biology of that is when you work the muscle, it knows it's going to have to change in size so it can do this work easier. It's going to trigger the mitochondria getting more active and the metabolism shifting. And so working it is very helpful. Now, in a couple of the other sections, we're going to talk about, well, what if I was injured and now I got to go back to working out, or what if I'm really untrained and I got to get back to working out. Obviously, there's a lot of technical things about getting back online, but building the muscle creates this long-term metabolism shift. And then if your diet is even at all insulin modulating, so it's not triggering excess amounts of insulin release, and that is usually by modulating the type of carbohydrate that you intake, et cetera, then you have the perfect combo. So the diet shift in a low glycemic type diet, and you can just look that's a very common topic on the internet, lots of charts and stuff, a lot of cool pictures, et cetera. But basically, if you look up low glycemic diet, they'll tell you the idea behind it, et cetera. But the idea behind it really is to have enough carbohydrates to go into your body to feed your body, but no excess amount. So the insulin release from your pancreas is appropriate. It's not excessive. Now, if you have insulin resistance, like I said, 45 to 55% of North Americans minimum have that, more in some areas. Your body's just going to be more responsive to either the good or the bad that we've talked about. So the metabolism shift in someone, say, with a insulin insensitivity or type 2 diabetes is going to be profoundly helpful to their body, just like it would be to anybody else. But because they have an excessive amount of the anti-hero, the fat and the insulin stuff going on, then that is a person who is going to benefit quite a bit more. Because they're going to attend to the muscle by making it work more over time. And then they're going to attend to the fat and insulin side by shifting their diet. We're just about out of time here. And this section is about muscle as medicine. We're going to move on and talk about some other things. Please like, share, subscribe, and do the notifications, because sometimes the algorithm puts us off in the corner and you won't know that that's going on. And I will see you in the next session.